All right. Next bit here is going to be on molecular formula. So molecular formula describe the structure of molecules. They tell you what atoms are in a particular molecule. And molecules are basically cases where you have different atoms that join together. They bond together using, we'll talk about later, you basically use by sharing electrons or taking electrons. And they form a bond together, and when they do so, they will form a molecule. Molecular formula, and the formula Formulae, the AE is plural, so this would be, you could also say molecular formulas, they mean the same thing. Can be written sort of as is shown in the bottom of your screen here. So first case here, H2O, water, one everyone is familiar with. What this simply indicates, a subscript down here indicates that this is the number of atoms of the previous element. So that means here we know that there have to be a total of 2 hydrogens. There's no subscript after the oxygen. When there's no subscript, that basically means there's a 1. You never write that down, so you never actually would put this on here. So that you wouldn't actually write that there. But it tells you that. If there is no subscript, that means that there is 1 here. So for this particular one, we know we have 2 hydrogens, we have 1 oxygen. Now that subscript, as we said, talks to the previous element. The only exception to that is that if on the, like say on our second one here, BaOH2, if there's a parentheses, like there is right there, the 2 talks to everything that happens before it. So in this case, that 2 distributes both to the hydrogen and to the oxygen. And so writing this guy out, we have barium, we have oxygen, we have hydrogen as our 3 elements in here. Is that barium, there's no number after barium, so that means there's just 1 barium right here. Oxygen is there's no number after the oxygen here, but since there is the 2 that talks to everything in the parentheses, that means that there's the implied 1 right there. 1 times 2 gives you 2 total. Same thing for the hydrogen. There's no number after it, so the implied 1 right there times 2 gives you 2. So that means that there's 1 barium, 2 oxygens, and 2 hydrogens. If we have more than 1 molecule, that's indicated by a number out front. The out front number, as you notice, is not a subscript, it's not a superscript, it's just a normal size number. It means that there are, in this case, 3 of everything that's right here. And so 3 AlCl3s. So for this one, if we wanted to find the total number, we have aluminum, we have chlorine right here, is that we say how many aluminums do we have? Nothing after it, that means there's a 1. So we have 1 aluminum there, but since we have 3 totals, 3 times 1 gives you 3. For chlorines, we have 3 chlorines right here, but there are 3 AlCls, so 3 3s is 9. And so that's how we get that right there. So that's how you basically figure out the number of each atom in a molecular formula. So let's do some example work, get an idea of how to set this up. So this one asks how many atoms of oxygen are in each of the following. So for our first one right here, we say, alright, let's take a look. Is there a subscript directly after the O? The answer is yes, it's right there, that 2. And so in this case, there is no number out front, so that means it's a 1. We don't have to worry about that. There's no parentheses here, so that means there are just 2 oxygens in that one. This one right here, there is no subscript after the O. There's no parentheses in here, so there's just 1 oxygen in NaOH, but there are 3 NaOHs, so 3 times 1 gives me 3. 3 oxygens in number 2. Alright, our next one, Al2SO43. So in this one, there is a 4 after the oxygen, so we have at least 4 of those, but the 3 distributes that, so that means that there are 3 4s, or 12 oxygens right here. No number out front, so we don't have to multiply it by anything. For this next one, we have 3 oxygens in that little piece right there, but the 2 distributes, so that means we have 3 times 2, we have 6 oxygens in this guy right here, but then we have another 6 out here, so we have 6 6s for a total of 36 oxygens in number 4. And that's how you'd work that out. For molecular mass. First thing, before you talk about molecular mass, you have to talk a little bit about atomic mass. And we discussed that a little bit earlier, but the atomic masses that you want to use for finding molecular mass are the ones that are on the periodic table. The only ones you won't use, the ones in the periodic table, are looking for neutrons, because those have to be whole numbers. The atomic masses that are given on the periodic table are basically averages of all the different isotopes at the levels that you'd find them on Earth. After the ding, we'll continue here. So for a molecular mass, what you have to do is the first step is to figure out how many of each atom are in your particular molecule. And so in this case right here, we have two elements. We have silicon and we have fluorine for this example. The next thing to figure out is the number, as we said. So we have how many silicons here? We have 1. How many fluorines? We have 4. All right. The next thing to figure out is going to be the atomic mass, like that. So we look at it for silicon. So silicon has, look up silicon here, has an atomic mass of 28.09. And we do want to always round these to the hundredths place. Fluorine, looking that up, fluorine has a mass of 18.998, which rounds up to 19.00. All right. So once we've got these two, the next step is basically what we can do is you multiply the number of each one times the mass of each one, and that's going to give you a total mass of each one. And so 1 times 28.09 just gives us 28.09. 4 times 19 is one that I should be able to do in my head, but I'm going to do it in the calculator just to make sure I don't make a mistake. So we said 4 times 19 is 76, and so we get 76.00 is the total amount of fluorine. And now at this point, to find the rest of this, we can just go ahead and add those two guys up. And so we would say 76 plus 28.09, so plus 28.09, and so we get a total of 104.09. And the unit is going to be AMU. For right now, we'll find there actually is another unit you can use, but this is the one that we will have for right now. So 104.09 AMU would be what we have for the molecular mass of SiF4, silicon fluoride. So on our next one, we're going to set this up the same way. This one, though, has 3 elements in it. So we have barium, we have carbon, we have oxygen. So let's first look at our number of each one. Looking at this, we have 2 bariums. Carbons, we have 1 that's inside here, but the 3 distributes, so that means we have 3 carbons total. Oxygens, we have 3 inside the parentheses, but the 3 distributes, gives us 9 oxygens. So for the atomic mass that we'll have here is the first one is barium. Looking up barium, it's sort of towards the bottom left, 137.33. Our next one is carbon. Looking that up, we have 12.01. And oxygen is our last mass here, 15.999, which rounds to 16.00 to the nearest hundredth. Once again, is that all we have to do is multiply the number of each atom times the atomic mass, and that'll give us the total mass of each one. And so, once again, it's calculator time. So we take our barium, so we have 2 times the mass of barium, 137.33. And for that we get 274.66. For carbon, 3 times 12.01. We multiply that together, we get 36.03. If you do the math on that. And then our last one, 9 times 16, which gives you 144.00. That's 0.00. And now at this point, as we did before, all we have to do is just add up those 3, and that will tell us the molecular mass of this compound. So we'd say the 274.66 plus 36.03 plus 144, and doing so gives us 454.69. So 454.69 AMU, or atomic mass units. And so that right there is going to be our final answer here on how to find molecular mass.